Welcome back to Part 2 of Chapter 2's Section 3 video lecture. In Part 2 today, we are going to be discussing, or in your guys' case reviewing, how to write or identify significant figures and how to write numbers into scientific notation. Significant figures, again, they indicate the precision of a measurement. And when we record significant figures, it's important that we include all known digits plus a final estimated digit. And you should see this paperclip. We did the paperclip lab in class. So the idea here is I'm looking at this ruler and it's in centimeters, and I definitely have 1, 2 centimeters, and then you can see the tick marks that are here, and it goes obviously out to the third tick mark, but it could be even just a little past that tick mark. So I can see from the ruler here that I've got a 2.3, and now this last digit here, the 2 again, this one, is the estimated digit. So I'm estimating that it's about 2/100ths, okay, like along the way there. So that's how we record those. So when we count significant figures, we count all the numbers except what we call leading zeros, these zeros that are out in the front. You'll often hear me refer to those as placeholders, as well as trailing zeros, zeros at the back end. Again, I just call these placeholding zeros. Let's go ahead and just explain why these answers here have as many significant figures as they do. So here our answer is 4 sig figs, and that's because it's obviously 1, 2, 3. Now this is probably the one where you're confused. See, it comes after a 0, so it says that we were able to measure down to this number. This is our estimated digit right here. I was for sure on whatever I was measuring able to get here, and here is my estimated digit. So that's why it's 1, 2, 3, 4. This next one we have 3 sig figs because again here's our 0, but remember kind of another rule is that if it's a sandwich 0 and it's obviously stuck between the 4 and the 2, then it counts as a sig fig. So there's 3 sig figs here. This one only has 3 significant figures because we have 1, 2, 3 here, digits, and then we have this 0 here that's in white. I would call this 0 just a placeholder, so that's why we only have 3 significant figures. However, and you might have seen this on some of your worksheets, if we add the decimal to the end here, we actually now would have 4 sig figs. Because we are able, this is the decimal is indicating that we are able to estimate the ones place. Then down here, our number 4, we only have 2 sig figs because these are just placeholders up front. Again, this is saying we were able to measure down to that degree here. So we were able to measure this, and these over here are just placeholders. Now significant figures rules do get a little tricky when we start to do calculations with them. So the first one that we're going to talk about, I think is the easiest, is that anytime you're multiplying or dividing, your answer is going to have the fewest number of sig figs that were in your, I always forget what we call those things that you're multiplying by. So if we look here at 13.91 grams per cubic centimeter, you can see that it has 4 sig figs. And sorry, again, my Mac is kind of screwing up the look of the PowerPoint. But anyways, 13.91 has 4 sig figs. 23.3 has 3 sig figs. So if I was to say which one is going to have the fewest sig figs, 3 is our lowest number. So I just am going to do the calculations like I totally would in my calculator, and if you can see in the white back here, our answer is going to be 324.103. Well, obviously there's like 6 sig figs in that big answer there, and we need to get it down to only 3. So the way that we do this is you'll look at your first 3, because obviously you'll want to include them, but then you'll want to look at the 4th or the next sig fig that you should include. And if this number was 5 or larger, you would want to round this last digit up. But in our case, this 4th digit is just a 1, so we're just going to leave our answer in 3 sig figs as 324. Now the rule does change when we do addition and subtraction. So the number with the fewest digits to the right of the decimal place determines the place of the last significant figure in the answer. So as you can see here, we have 3.75 plus 4.1, and our answer would come out to be this, except for we have to adjust our answer to be more correct in science. So when we do our answer, we come out with 7.85. However, if we look at 4.1, do you see there's nothing in the hundreds place here? So basically what we have to do is we have to make sure that our final answer doesn't have anything in the hundreds place. So what we'll do again, just kind of like we did on the last slide, is we'll look at this number. It's obviously a 5 or higher, so we'll need to round our answer up. We have another example on the next slide. Again, here's another example, and so this time though we're working with whole numbers, and so you want to round the final significant figure. Make sure it's in the same place as the leftmost uncertain digit. So here we have 224 plus 130. You can see the last significant figure here is this 4. The last significant figure here is a 3. And so we're just going to add it up just like we normally would, but now we know that we cannot have a number that's not 0 in this 1's place. So what we do is this 4 is smaller than 5, and so we're just going to leave it our answer as 350. Another rule to know when we're talking about significant digits or significant figures is that when we're looking to do like a multiplication division problem and we're trying to count those number of sig figs, there's some things that you won't include to determine the number of sig figs your answer should have. So if we had an exact number, like such as 12 students late for class, there's no significant figures associated with 12 because you're certain that it's 12 students. It's not like I'd have 12 and an arm walk into the room. I'd have 12 whole students come in. We also don't take into consider exact conversions. So for example, if I was doing something like 662 and I was trying to get it into centimeters, I don't know, let's say this was meters. Okay, my final answer is going to have 2 significant figures here because you might be like, well, there's only a 1 here, Miss Semino. Well, the idea is that this is a conversion factor, so it will not affect the outcome of my results. So my answer should have 2 significant figures. And in this case, because I know you guys always like the answers, my answer would be 0.62. Oh, I lied. I went the wrong way. Okay. So our final answer here would be 6200 centimeters. And again, you're like, what, Miss Semino? There's 4 numbers here. Yes, but only 2 of them are significant. These other 2 are just placeholders. So that's how I would come up with my answer. And the last, the 1, as we kind of just discussed in a conversion factor, doesn't count against you either. So let's go ahead and look at a few more practice problems here. So here we have a division problem, and remember the rule for division is we just look for the fewest number of sig figs to determine the answer. So we've got 15.30 grams divided by 6.4 milliliters, and so it looks like we're finding some density here. So here we have 4 significant figures or digits in this one, 2 significant digits in this, so our final answer must only have 2 because that's the fewest number of significant digits. When I calculate my answer, it comes out to be this long monster number. But if I want to do this properly, notice what our final answer is, 2.4. We came up with that answer because we went 1, 2, 3. We looked at the third place. The third place is bigger than 5, so we're going to round this digit to 4 as we did here. Let's look at example number 6 here. You can see we've got 18.9, 5. Sorry, I was distracted. My Mac is screwing up how this is looking again. But the idea here is, let's see, we have a significant figure here in the tens place. We have one in the hundreds place, but since there's nothing in the hundreds place over here, our answer can't have a number in the hundreds place. So we just calculated just like we normally would, 18.9 minus 0.84. This is our answer we come up with. Again, we look at this last digit here. It's bigger than a 5, so we'll want to round this digit, so it should be 18.1 grams, and you can see in our answer here, that's what we came up with. Now, in scientific notation, you should have watched another little video explaining how to do this, and I'm sure it's going to be much better than this explanation. But we like scientific notation because it helps us write numbers in a more easy way, and it helps us compare numbers as well. So when we convert into scientific notation, we want to move until there's 1 digit to its left. So places moved equals the exponent. So remember we talked about exponents in class as being more of an instruction. So if you have a large number, such as a number greater than 1, you're going to have a positive exponent. And if you have a small number, such as -1, you're going to have to make sure that your answer includes a negative exponent. That's just a good double check to make sure that you've written your number correctly. And again, you only want to include significant digits when you're writing in scientific notation. So let's go ahead and see how we wrote these. So we have 2,400,000, so this is a pretty big number, maybe time-consuming to write, difficult to compare. So the way that we would do this, I hope you guys can tell that these boxes are kind of tons, like should be multiplication. I should write that in for you. So 2.4 times 10 to the 6th here. And so the reason we came up with 10 to the 6th is we've got 1, 2, 3, 4, 5, 6. So our decimal is going to be placed right here, so that's why it needs to be 10 to the 6th. Over here, for number 8, if we look at this one, we can see right away that this number is smaller than 1. So in your brain, I hope that it's popping up, that you're like, oh, this is going to have a negative exponent associated with it. So again, let me get my little pen out. So in order to get the 2 into the 1's place, it's going to be 1, 2, 3. So I had to move the decimal place over 3 spots to eventually make the decimal here. So our answer is going to be 2.56 times 10 to the, and this should be negative third up here. This is the exponent right here, guys. Let's look at the next problem, and this is 7 times 10. This time we're going to be writing our something in scientific notation in standard form. So again, the clue here is that you have a negative exponent. So what will the answer be? Will it be bigger than 1 or smaller than 1? I'm hoping that you're saying that the number should be smaller than 1. And so we're just going to write our 7, come out 1, 2, 3, 4, 5 spots, and that's how we know how many places and where to place the decimal. Let's do this next one. This is 6.2 times 10 to the 4th. This is our exponent here. And so again, we're just going to move our decimal over, in this case 4 spots. So we'd go 6.2, 1, 2, 3, 4, plop those zeros in there. There you go. So we're at 62,000 millimeters. Here on this slide, it kind of just gives you an example of how you can enter things into your calculator with scientific notation. I'm going to skip this one because everybody should know how to use their own calculator at this point. And the last thing that I want to talk about is a direct proportion versus an inverse proportion graph. So I think there is like a question or two on your test about this. So the first thing that I want to say is a direct proportion means, let me just change the color of my pen here, means that there is a direct relationship. And sometimes, so if our x value will equal our y value, we'll get a line that looks like this, kind of going up at the same rate. On the other hand, if it is a inverse relationship, they don't increase at the same rate. And so we get this, I guess I want to call it a parabola. I'm not a math teacher. You guys can school me on this tomorrow. So, but then maybe here, x is equaling 1 over y. So it's an inverse or the opposite, I kind of think of it. And so we'll get this curved shaped line. That was a super fast review of significant figures that I made before school today. I hope that's helpful in your studying. Please stop by and ask me any questions you have after school. Thank you. Bye.